In this video, I'm going to be talking about another approach for biomedical event extraction, but this time we are using contextualized representations, for example, using pre-trained sciBert model. So this paper in 2023. Biomedical event extraction is applied to biomedical text to obtain a list of events within the biomedical domain. The best genuine biomedical event extraction research uses sequence labeling techniques with a joint approach, softmax decoder for event trigger identification and biobert encoder. However, this event extraction model has three drawbacks. Tasks are carried out independently. It does not provide special handling of multi-label event trigger labels, and it uses an encoder with vocabulary from non-biomedical domains. We propose to use the pipeline approach to provide forward information sigmoid to address multi-label event trigger label and alternative BERT encoders with vocabulary from the biomedical domain. The experiment showed that the performance of the biomedical event extraction model increased after changing the encoder, which had been built using a biomedical specific domain vocabulary. Changing the encoder to sciBert while still using the joint approach and softmax decoder increased the precision by 4.22 points and resulted in F1 score of still this F1 score is very low, still below 70 or 80%. So the first step in event representation is a token labeling process. Each token in the sentence has three predefined labels. So we have DRH. R is the label assigned to specific code to simplify the notation. So the R label is assigned a special code to simplify the notation process. For example, the code regulation 1 indicates that this protein entity or event has a relationship with the first regulation event located on the right. So denoted by plus sign on the plus. If the event's position is the first on the left, the position would be -1. If it is 2 times on the left, so it is -2, and you got the idea. It's a relative distance. So we have regulation, the event type, and one of the entities, for example, protein. And we see if it is, for example, this is the event type, and then the distance is -2, or the distance could be -3. Or it could be at the right-hand side, so distance +1 and etc. So this is a very good source of information that very few papers have noticed that this is a very important feature. So for regulation, expression scheme regulation -1, expression -1, and you see DRH, the head-end dependent. For example, for cause, you see your dependent is protein and your head is regulation 1. So I've explained this in part 3 that it's based on the joint approach that the event trigger identification task undergoes 2 adjustments. And finally, BERT encoder uses the original joint approach, is replaced with BERT models that have been trained, and specifically sciBert and PubMed BERT are selected due to superior performance compared to initial BioBERT. So sciBert and PubMed for this task is better than BioBERT. So this is the architecture. You get the protein masking, then event masking, and you get the event trigger here, and here arguments and its values. But you can do it in 2 different ways, the pipeline or the joint approach. So after you give it to protein masking module, both of them, you can either first do event trigger identification and then relation extraction, which are important for event extraction, or you can do it in jointly, train them jointly. So this is event masking for module 1. And the thing that you are masking is here. So it's a simple event, theme 1 argument, and its words the protein. It has some event label. It could be a binding. It could be complex event. It could be a combination of simple events and binding. It could be a combination of simple event and complex event. So there are different groups of events. And you see different event masking for them. For example, in this text, data suggests that this may all be in regulating this transcription. So it's a biomedical text. And we have this annotation. You get this entity, protein, and then regulation, protein, transcription. But the mask text is recently data suggests that. So instead of this, we write protein. And it infers, so it's learning that it is a protein. May also be involved in, so this is an event, regulation is an event. This is again entity. And so we use different tokens. This is a mask token. So if you have sciBert, you mask it here, for example, $some event, and your event could be regulation. So you are learning these things. So you see that sciBert, if you use softmax, then sciBert and PubMed are better. For example, sciBert has a better F1 score in comparison to PubMed. And you see both BioBERT versions have low F1 score. So it is better to use sciBert and PubMed BERT. But still, state of the art is less than 80%. So you see event extraction is still in its infancy. So the application of pipeline method to replace the joint method and substitution of sigmoid decoder for softmax did not enhance the performance. However, replacing BERT encoders with biomedical specific ones resulted in improved model performance. Specifically, changing the softmax decoder to the sigmoid decoder improved the performance of event trigger, but it did not lead to any overall increase in event extraction model's performance. The experimental results indicate the sciBert encoder demonstrated the best performance in identifying event triggers or dependency labels, achieving a F1 score of still less than 80%, so it has room for improvement.